Basically, it's been a lot of talks about AI in the last couple of years, in the last 2 years to be exact. But actually, there's a lot of misleading information out there. The AI today is definitely not the AI that we think in Terminator, in Matrix. That is basically still in the lab. So the research world of the AI are basically differentiating itself into two different AI. One is what we call strong or real AI, and the other one is the weak AI. The strong AI is basically what we imagine in the Terminator, in the Matrix, or all the fantasy movies. That is basically still in the lab. That is non-existent yet. So we basically still don't know how to actually destroy ourselves by AI. The weak AI is basically the result of the last 80 years of the AI development, especially in the last 10 years or so. And it's being used in a very practical usage, especially in a very small activity applications, and I'll go through it. It cannot replicate humans. It can only help human in a very certain ways. For example, think of computer. Computer is not human, but it can do a lot of things much better than human. It can compute mathematical calculations in a seconds, in a millimeter of seconds. Compared to human, we cannot compare to computers, but we can create computers. We can create the formula. Computers cannot create formulas. This is basically the evolutions of AI in the last 70, 80 years or so. The first AI boom basically in the 1960s where, I mean, for example, NASA was trying to replace the human calculators by using the first IBM computers. And then in the 1980s, the born of neural network basically enhanced the applications of like weather forecasting, like our traffic light management, our train or schedule system. This has been in the work of our daily lives in the last number of decades. After the 21st centuries, the evolution of machine learning basically pushed AI to a new era of thought. We are no longer in numerical statistics. We are basically into another way of trying to make AI to replicate human brains instead of just trying from another way of computations. And not until 2010, 2012, we have a huge leap in AI, which is called deep learning. It's basically a product of Dr. Geoff Hinton, a professor from University of Toronto, and also a Google employee, that basically introduced he wasn't the one who introduced the theory of deep learning, but he was basically the first person to actually prove that it can actually apply into a very specific technology. So what is actually AI? There's a lot of discussion in this, but we're just trying to actually make it into a framework of machine learning. And part of the machine learning is basically neural network. It's trying to mimic how our human brains process information. And within neural network, deep learning, convolutional neural network, recurrent neural network, I'm not going to go into detail of each term, but basically, this is our human's neural network. We're trying to mimic, what AI does is just trying to process the information, to use AI to actually replicate how our brain is processing the information to reach a certain result. And as a result of this, several very detailed applications was born. For example, deep learning in the video stream analysis, long short-term memory in speech recognition, especially in the last 5-6 years. Google Translate has advanced a lot. But you know it's not there yet because it cannot translate the meaning, it just translates the word. There's no soul in the translation. Image recognition in the last couple of years, since Google bought Dr. Geoff Hinton onto the lab, basically image recognition has been successfully pushed out to the commercial world. Well, LDA, big data analysis, which has been there for, well, since we had the computer, and NLP, the progress of NLP has been the focus of the AI research in the last 30 years. And because of the RNN, we are now able to see where we are going to head to in the next 10 or 20 years. This is a bit of evolution of how AI will be in the next 20 years or so. At this stage, since the introduction of deep learning, we can already improve the accuracy of what we do. For example, weather forecast, for example, traffic light system, it has become much more accurate. And why is that so? It's simply AI is basically helping us to process the information in a much better accuracy or less error percentage. Human beings, although we can create, but our memory, the type of memory, active memory that we had in our brain, doesn't really help us to contain the information all the time. Therefore, our accuracy rate is only within 60 to 70%, depending on different person. However, a computer can always contain a much higher accuracy. And deep learning has been successfully delivered a 95% accuracy product, which only 5% error rate. And this is a comparison between a human and a machine at this stage. In 5 years' time, or 5 years' time, we forecast that we are able to understand emotion in a much better way. For example, the robot in Japan are now able to recognize about 36 impressions of human faces, where the robot will understand whether am I sad, happy, and build reaction onto it. It's able to plan by itself. It's able to improve the environment recognition. For example, you know, by scanning this room, it's able to identify how many human beings are in this room, how many tables, how many chairs, in a much better way, what type of chair it is. We still cannot predict who you are simply because we don't have your information. We don't have access to your information. I don't know whether Mark is here or Terence is here. I just simply know this is an object. This is a human object. But I don't know who you are unless I'm able to connect to a database where this person has a record on it. Therefore, AI still cannot create. Personal assistant, chatbot, in a much more human way. Self-driving car, which are already in a lot of work. Robotic, helping assist us to do better in our redundant work. For example, housework, nursing care, so on and so forth. Now, in 2025, again, this is just approximate. We believe NLP will reach to the level that natural language processing will reach to the level that we are able to understand and translate human language into a context. It's no longer just word-to-word translation. It's able to speak like us. To understand what, by using facial recognition, by using emotional understanding, we are able to understand what you're saying and how should I be responding. And therefore, it will be able to use it in a mass scale, for example, in e-commerce, in daily conversations, some redundant job like secretary, reception, so on and so forth. I'm not going into the topic of whether it will create some job losses or not, because simply this is just the evolution of history. When computer was invented, we lost a lot of jobs. But today, we just have a lot of new jobs as well. Human will evolve. Human will evolve to learn new skills into the new environment. Can you imagine today's world without cell phone? But 10 years ago, we just couldn't imagine. In 2030, massive knowledge understanding. Again, this is what we forecast, or what I would say, majority of AI researchers forecast that it will basically understand human beings and able to create, to give an example, we may be able to create a 15-year-old person that has limited knowledge, but able to do a lot of our jobs. But we are not able to create an experienced person like yourself, a 50-year-old experience that has been through the life that no one can replicate you. This is what AI researchers believe, although there are a lot of theory out there saying that singularity, end of the world, is going to, well, there may be simply because there are some parts of the AI are basically not understand, we call it black box. The computation of deep learning, there's a part of it are not able to identify or understand by the human. Simply, we just create a machine to run itself. I mean, for example, when you think of a machine to stitch, to draw certain things, you know how it can be done, and that's why you feel okay. But when you don't know something is being done, then you have fear of it. What is it going to, how was it created? Could it be possibly creating something else? Basically, to AI researchers, we have no fear. We rather fear, I'm sorry to go into a bit of biogenetic, but for example, 15, 20 years ago, we created Dolly in England, a doll. That is, to me, much more fear than AI. Did we create another being? Did we create another soul? Or is it the same soul? We simply don't know. What was it? We simply don't know whether is it a soul. That is the job of God. That is not the job of human beings. And much critics are being put into AI rather than the genetic DNA coding. So it's a controversial. At the moment, there are a lot of different applications are already being done by using the AI technology that we have today. And for example, advanced business intelligence, voice, sensor data, video stream data. I'm going to put into context in a real example later. Drone, auto drive, customer support, education, legal, manufacturing. But basically, there are three big trends in today, and maybe next year as well, which is basically IPA, Intelligent Process Automation, where we use it to automate business operations. This is not just about AI. This has been done by human regardless of whether it's there AI or not. Human will need to find the ways. CEO will need to make sure that your profit, your earning per share is increased every year. This has to be done. Whether it's done by AI or not, it's just another method of doing it. Smart workflow. In marketing, advanced business intelligence, alerting for further actions, knowledge extraction, user experience using chatbot, combining with, let's say, an AR, augmented reality. You can basically replace, let's say, tellers or receptions to basically advance. I mean, there are a lot of hotels in Japan that have already used AI and virtual augmented reality to replace those redundant jobs. Hotel receptionists, for example. There are quite a few hotels in Tokyo that are already doing this. Now, I'm going to go a bit about what we've done. In the last 3 years, we have a lab in Tokyo, Japan, and Vietnam that we have gathered a group of researchers and engineers, more than 100 over of them. And before AI became a wow word, since Mark Zuckerberg, Facebook, in 2016, trying to create his own chatbot. We've done that. We've begun from 2014, 15, around there, by gathering a few AI researchers in Tokyo, in Keio University, and as well as Vietnam as well, to basically try to do something by ourselves. I wouldn't say just for fun, but we didn't have an objective that time. That's why we call it a lab. And opportunities came when AI became a hype. So therefore, we use what we have found to actually apply it onto business world. And there are a number of applications that were being used on the actual case, especially in Japan and starting in Europe together with Nexus. And I'm just going to go through Intelligent Document Scanner. This is not OCR. OCR, as you know, has an accuracy of less than 50%. This is AI scanning where we're able to deliver up to 99.5% of accuracy. Where, for example, in Tokyo, we help a logistics company to basically reduce. So logistics company, when you actually go to let's say FedEx, you write down all whatever information on the piece of papers, and then you try to convey the information into the computer, and then process it to the warehouse, the logistics, the information system. That has been very slow, and a lot of human labor are being used in it. But what we've done is basically to create an automatic scanning system where it's able to scan the vital information on the paper into the system where it can immediately convey to the whole supply chain, where it basically increases the process of the workflow by, let's say, 30%, 40%, and also reduce the workforce by number of percentage. Another example is a legal firm. A legal firm, as a professional legal, what you can do for a case is, let's say, a normal selling and purchase agreement will still need to take you at least 4 to 5 man-hours to actually draft up the legal contract, explain to the clients, and so on. But that is money. For any professional, especially consulting work, our time is money. And that is not scalable because depending on number of labor you have, you can only scale to the proportionate. But what we've done for this firm is they have about 40 legal associates, which we can already predict what they are going to the output is going to have, and determines the shares of the company, the share price of the company as well. But what we've done is basically using AI to abstract the key information in the legal terms and create a standard format. So we are using AI to replace 90% of the associate's job, and the associates itself will interpret the last 10%, which theoretically we're increasing the efficiency by 90% of the associate. And therefore, with the same number of workforce, we are now able to push the possibilities of the firm by another number of X, by reducing all the efficiency, flows, accidental, implemental issues is at least 5X of efficiency. And that can basically translate into the valuation of the company and actual output of the company as well. Intelligent Business Alert, basically, right now, the loss of customers, we call it churn rate, basically, it's not real time. You can only understand the client's prospect after you actually receive the result, and then only you actually push it to the processing center to understand. You receive the summary, then you create response later, but you have already lost the customer. The churn rate is always high. We are using AI to actually monitor the real response from the client and create a response to the customer service agent to say, you know, let's say mobile phone contracts. Right now is just, can I offer you a discount and then stay with us? But what we can do is basically providing the real information. Why are you thinking of leaving? Instead of just providing money, can I offer you something, family package or something, that will decrease the churn rate. Nexus Recommender. This is basically recommendation. We believe using historical data, well, everybody says AI needs data. To us, it's totally wrong. AI is not about data. Using historical data does not create the right perspective, the right future. And many companies, 90% of companies don't have data. So what we're using is basically horizontal attributes. What you like to do is not exactly based on what you have done. Human beings like to do something that they have not done or your preference in the future. So we're using basically horizontal attributes to predict what is happening in the future. Data extraction, we have basically invented to run deep learning models rather than on the cloud. We can actually run it in the camera itself. And that will basically give us a live feedback. So imagine we help a very large clothing store a worldwide clothing store in Japan to actually build a prototype to basically build the AI security cameras into the store to exactly understand what the human wants. We can identify what are you holding on your hand. It's not just about heat map, where are you standing, or how many people has entered your store, so that you can allocate where you want to put your resources in. No, it's about what are you holding on your hand? Who are you? What should you be doing? Is your wife nagging you to buy or not? We can basically interpret those information on the camera itself to provide a much faster response, because infrastructure today does not allow a large data graphics transfer, as well as voice recognition as well. Not only graphics, but voice. Right, so basically, I'm going to wrap up. What do we think in the future the managers or human beings should learn to work alongside with artificial intelligence or any technology? It's basically the creativity to create. We can control technology because it was invented by us. Skills to design the business models. We need to have leadership and management skills to manage the process because we created it, and we need to create more. Problem solving. There will always be problems when implementing certain technology into the workflow. The skills to take care of the emotional part, which AI 100% cannot take it at the moment. And we don't have a roadmap of how we can actually create an AI that has emotion yet. Before I finish, I'm just trying to differentiate all these frontier technologies, AI, IoT, blockchain. Of course, there are more. But think of AI as an engine of a car, whether you have a V6 engine, V8 engine. Think of IoT as the tire to deliver the product to another place. For example, your mobile phone is an IoT product. Think of blockchain as a body, as a process. Blockchain, to me, sorry to go into a bit, is basically like an internet, e-commerce in the 1999 during the dot-com bubble. Basically, we know the potential, but during that time, the HTML website does not provide enough credential or enough tools for people to actually buy something on the internet. The infrastructure, everything, does not give the environment for you to actually use e-commerce that time. But 10 years later, it's already common for us to buy things online. And it's the same as blockchain as well, where the technology will evolve, the hardware will evolve to save energy. It's not efficient at all to run a country's energy on a certain technology. It's basically not economical sense. So I'm going to close my note about AI and the comparison of these. Hopefully, it will help you to understand a bit more about how can AI actually help.